This is phase 5, and if we're here, it means there must be two or more method declarations that are both accessible and applicable. And the objective of this phase is to select the method which is the most specific. And we say that one method is more specific than the other. Basically, if any call of one method could call the other method without any compiler error. And if we have two methods with the same fixed arity, the same fixed number of arguments, then one is more specific than the other if every argument type is a subtype of the other argument type. So for example, if you've got this method which takes these three arguments of this type, I've not bothered putting the argument names in here, we say that that's more specific than this other method which takes those three types if each of the types is a subtype of the other. Now subtype means that it can be the same, by the way, so it could be a proper subtype or the same type. Now a couple of points to mention. If we got here because of it's applicable by subtyping or it's applicable by method invocation conversion, then there's going to be the same number of arguments in each case. And what's more, if one of those methods was a variable arity method, as the example I gave in the previous slide, all we have to note is that we just happen to have an array here. Right, now if we got here from phase 4, then we got two variable arity methods that we're looking at. So we're looking at least two. So if we got two variable arity methods, we say that one is more specific than the other. If well, the same sort of thing holds, you just if you run out of argument types, you just keep reusing the S2 in this case, for example. And similarly, if the first one's a bit short, you just keep reusing the first T2 in this case. Right, now you can end up with two methods, each being more specific than the other. And that'll happen if they've both got the same signature. And it can also happen if you introduce generics. And this leads to the idea of strictly more specific, where only one is more specific than the other. Now we come to the concept of maximally specific, and what you do basically is if you find a method where one is strictly more specific than the other, just throw away the least specific and you'll just be left with a set of maximally specific methods. Now if there's only one maximally specific method, then you've found the most specific method and that's it, you're finished. If there's more than one maximally specific method, and there's a couple of requirements. They have to all be override equivalent, or you get a compiler error. And override equivalent means that it's got the same signature, or in fact, you can weaken that slightly with generics, but it's basically the same signature. Okay, so here's an example. There's two methods, a call, and that's very important for determining what happens. Both of those methods are maximally specific. And if you think about it, they're both going to be selected in phase 3, which is dealing with applicable by method invocation conversion, because you have to do boxing. Now, integer is not a supertype or a subtype of int, so they're quite different. So they both end up being maximally specific. One is not strictly more specific than the other, either way, so they're both maximally specific. However, the signatures are not override equivalent, and therefore the compiler will give an error complaining that the call is ambiguous. Right then, pretty clearly, not all of these maximally specific override equivalent methods that we've ended up with can be concrete, or the call is ambiguous if it is. Now, in fact, there can only be at most one concrete method, in which case that's the most specific method and you're finished. If you see more than one concrete method, that's an error. It's an ambiguous call and it's a compiler error. Right then, so now we've left dealing with a whole load of maximally specific override equivalent methods that are all abstract. So what we do is we look at those with the most specific return type. Now you can only end up getting a different return type if you use generics. So it's a bit hard to illustrate that at this stage, but what happens and what you do is you select the method with the most specific return type, and if you've got a whole load with the same return type, what you do is you choose it arbitrarily from the set, and it's considered to throw those exceptions which are common to all of the maximally specific and override equivalent methods. Okay, now you might say, well, this is all arbitrary, yeah? Well, the only time that it's arbitrary is when it doesn't matter, because any concrete implementation will have to force this requirement, at least as far as exceptions is concerned, onto the methods, abstract methods. So in fact it works. And if you have to go back and look at our previous discussion on overriding to see that that's the case. Alright, now I think it's time to give an example because this has got really complicated.